as well as in the commercial sector, that are taking advantage of this incredible power that you can pack in a very small space. This particular satellite is designed as an imaging satellite, and it's important for the Army to be able to do imagery. And what sets this apart from other systems that have been developed in the past is it has the capability to directly send that image to the user on the ground, and to do that in a very short period of time. From the time it's asked to take the picture to the time it sends the picture down to the ground and appears on a laptop on the ground, very, very short period of time, measured in maybe 1 to 2 minutes. So I'm going to turn it over to my colleague Chip Hardy here in just a moment. Let me have one more slide, please, and I'll turn it over to Chip. Have the next slide, please. So that this really tells you the three key tenets of the program. The first one is low cost. It is not only small, but it doesn't cost much. And that's important for anybody that's developing space systems, but it really is remarkable how low cost these systems are today and still have the capability they have. The second point is survivability. They are inherently survivable, operating in low Earth orbit. And finally, and most importantly, the one I've already talked to you about is the responsiveness aspect, the ability to get that imagery to the ground very, very rapidly. So I'm going to turn it over to Chip and let him talk to you about the specifics of the spacecraft. So Chip, take it away.
Thank you, John. As John said, my name is Chip Hardy, and I'm the Government Program Manager for the Kestrel-I development effort. As John indicated, Kestrel-I is a small microsatellite class satellite whose job is to provide tactically useful images to the at the tactical level to the user on the ground. What we are doing off the space station is an experiment that, if successful, could lead to an objective system. The main main benefit of Kestrel-I is not to provide high quality images, but rather, being low cost, you can have many satellites to populate a constellation in order to have one persistently or frequently overhead to provide some persistent presence. And then the final point to make is that being low cost and having many satellites, when you launch or having a failure at launch or an anomaly with a single satellite unit, does not lead to a loss of service. Therefore, you have graceful degradation. It is a joint capability technology demonstration program. This is a special program within Office of Secretary of Defense. And as such, we have a COCOM sponsor, Combatant Command sponsor, that's Pacific Command. Once we're on orbit, a large part of the experiment will be to evaluate its utility, and so the PACOM will do an assessment of that.
Chip gets the tough duty of doing the experiment over in Oahu, so he'll have to spend at least a month over there. But somebody had to do it, and Chip volunteered.
That's right. So I think subject to questions, Tabitha, that's all we had.
Okay, great. Thank you both. If we have questions in the room, please raise your hand. Wait for the microphone to make its way to you. And if you have questions and you're following along online, please submit that via the hashtag AskNASA. Any questions in the room for these gentlemen? We have a question up front. Please wait for the microphone.
What kind of devices will be on the ground receiving images from this satellite?
So we have, for the JCTD, like I said, as an experiment, we have 2 ground stations. One is at our place of business, Redstone Arsenal, Alabama, and the other one will be at Pacific Command in Honolulu. The one at Redstone is a fixed site antenna. The one at Pacific Command is a highly mobile antenna called the Gator, and it is an inflatable antenna that has great logistics impact in that it is lightweight compared to a traditional antenna. You save about an order of magnitude in weight and still get the same performance.
The antenna that Chip's talking about, if I can just add to that, it is very lightweight, and it can be, you can take the entire antenna system. It's a 2.4 meter